So welcome, my dears, back. Suppose that now I just want to draw graph this. I will show you. I just want to graph this figure, which will be shown up to you right now. Here, let's go here. And I want to graph this figure, which is in front of you. Here, y will equal x minus 1 all square plus 3. We call this quadratic form. Quadratic form. Quadratic form from quad. Quad means 2. Because the power here of this is 2. Like what you see here in front of you, the power here is 2. So also, same likewise what I did yesterday, I will just put the share off right now and work on it in the board, but I will write the equilibrium first so that everyone can know what we are doing. Just I will stop share and I will direct the to the board here so that you guys can see the board, clearly can see the board. And I will start working here right now on that board, just make it close up a little bit. And here we go like this. We also have here, I think that's fine now. Or maybe if I get it a little bit like this, that will be more fine. So I have let's see our own PowerPoint. Here it is. We have y equal x minus 1 all square plus 3 x minus 1 all square plus 3. This is minus 1. X minus 1 all square plus 3. Let me just now go to how to graph it, and just to say also the domain and the range, and just to comment about the situation here, about the situation in this figure, how it looks like. So my first point here is just to go into the explanation. So I have here x. I will put for x numbers. I will put for x numbers. As an example, here is x. And here is y. Y is x minus 1 all squared plus 3. So as example, when I say x will equal minus 1. So here, minus 1 all square plus 3. So minus 1 all square plus 3. So this will be minus 2 all square means 4. 4 plus, this is minus 2 squared will be 4 plus 3. That will give me 7. So here, that will be 7. I will put also on the level of 0. So if x is 0, x minus 1, 0 minus 1 all square plus 3. So x, I suppose that x is 0, x minus 1 all square plus 3. So this is minus 1 multiplied by minus 1 will be 1. 1 plus 3, that will equal 4. So here it will be 4. In front of 0 here, it will be 4. Okay, let me just give another 4 or 5 example numbers. Then we'll go for the solution of this problem. I will just remove those two now. We're done for those two. We don't need them anymore. I will keep only the function, and I will keep the rest of the numbers here. So now I will go to the third one. Let's say 1. Let's say 1. So this one means if I put x equal 1, that x will be 1 minus 1, here 1 minus 1, all square plus 3. 1 minus 1 is 0. 0 square is 0. Plus 3, that will equal 3. Here we go. This is 3. Now I will put x minus 1 all square. I will put x with 2 will equal 2. So 2 minus 1 Let us remove this so that you guys will not be confused between both of them. Here we go. Now x is 2. 2 minus 1. I'm substituting in this formula right now. I'm substituting this formula. 2 minus 1 all square plus 3. So this is 1 square, means 1 plus 3, that will give me 4. So here it is, 4. I will go now to equal 2, 3. Let's do it equal 3. So here, we'll substitute in the formula. That will equal 3 minus 1 all square plus 3. This will be 2. 2 square will be 4. 4 plus 3, that will give me 7. So I will put here 7. So I have here now the pair of the answers here and the pair of these answers. So if there's minus 1, minus 1, and minus 1, this is minus 2. Minus 2 become 4 positive. 4 plus 3 will give me 7. 0 minus 1, this will be 1. 1 plus 3, that will give me 4. 1 minus 1, that is 0. 0 square is 0, plus 3 is 3. 2 minus 1, that's 1. 1 all square is 1, plus 3, that will give me 4. And finally, 3 minus 1, that's 2. 2 square is 4. 4 and 3, 7. Now, what I will do is just graph these points, the x and y. I will graph now these points. Like I did before, I will graph these points. Good, that's fine. I have the largest point is 7 for the y, and the largest point is x3. So I will do the graph like this way now. I will do my graph like this way. And I will go for 1, 2, 3, 4, 5, 6. Here, minus 1. Here, minus 2. Here, minus 3. Minus 4. And up 1, 2, 3, 4, 5, 6, 7, 8. And we'll go down also. We'll go down into minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. Now I have to graph these points. I have to graph these points. Minus 1 and 7, that means I will go minus 1 and go up till 7. Here is the point, minus 1 and 7. 0 and 4, so this is 0 and 4. Here it is 0, x means I'm not going to x, and I will go up 4. 1 and 3, this is 1 and this is 3. Here it is 2 and 4. 2 and 4. Here is 2, and here I will go to 4. So I have here 0, 2 and 4. Then 3 and 7. 3 and 7 back. Here 3 and 7. Here it is. Okay, guys. Then I will take this point back like this way. I have a curve right now in front of me. We have a curve. We created a curve by this way. So this is the graph. It will be a symmetry. A symmetry means similar, but doesn't go to the point of x, 0 and 0. That's fine, but still there is a symmetry. So this part and this part are almost the same. But the range now, if I want to put the range x belong to any real number, all the real numbers. That's true. But we have a condition. We don't have a condition here. X can take all the numbers, while y, or the range, the domain, this is the domain, this is the range, this is the domain of x, the range of y, the range of y. Y belong to all real numbers, but I have a condition because y start from 3. Y here does not start from 0. So I would say with a condition. I make a print like this, just like this. Just 1 second. Y belong to all real numbers, but with one condition. With one condition, this is one condition, that y is greater than or equal 3. Because y starts from 3 and going down upward. It's also all the real numbers, but y is greater than or equal 3. That was the first point which we work on today. And this is an example of how to do this function. I will just go back into the example which I discussed on the portal right now, and I will share the screen. And I will share the screen to show you this example here, what we did. Here we go. Like you see here, it's the same one which we did on the portal a few minutes ago, and you can see here on the portal, this is our example, and this is our graph. The graph is here. The same graph is here exactly. And what you see here, the domain and the range, like what we did here, the domain and the range. X belong to all the real numbers. This is the domain. And the range, y belong to all real numbers, but y is greater than 3, because like you see here, we have the y did not start from the 0, start from 3. What about the vertex? Where is the vertex? What do we mean by the word vertex? The vertex. The vertex here is the bottom of that curve. The vertex is the point where the curve will change its situation. We have actually, for the vertex, like you see here, the vertex in this point, the lowest point in the curve. Here it is, where the curve will turn back. This we call it vertex, where the turn the curve will turn back. So here in this point, the curve will turn back in the point 1, x equal 1, and y equal 3, here in this point exactly. And I will just show it right now on the graph. And the vertex on the point 1 and 3, here it is, and here it will be. So here 1 and 3, the bottom of the curve. As long as x is 1 or greater than 1, then I have the minimum on the vertex. So here, x was greater than 1 in all the cases in the minimum of the vertex, and it will show this very close by. This was a quadratic form. This was a quadratic form. Again, I will stop share here, and I will show the vertex on the board. Here is the vertex, this point. I will make it with red pen so that you guys can see it. Here is the vertex in this point, here, down. The bottom of the curve down, this is the vertex in this point exactly. This is the vertex. I can see the red now, the red color. This is, we call it, I will just, because vertex, V-E-R-T-E-X, vertex. We call it the vertex. Why? Because the turn, there will be a turning point here. Like it looks like the turning point. And this is the lowest point in the whole curve. We call it the vertex. And we have two types of vertex. In this vertex, it's minimum, M-I-N. It's a minimum because it's closed down like what you see here. But we have another also vertex when it's the opposite, when it's maximum on the other side. Shall go for the next part. Thank you so much.